Hello, welcome to Lesson 4 of Module 1 of my new course on Networking Fundamentals. In this lesson, we're going to be picking apart switches, and we're going to show you everything a switch does to facilitate communication. As we discussed in the first lesson, switching is the process of moving data within networks, and a switch is simply a device whose primary purpose is switching. We're about to show you an illustration of a switch and everything it does to funnel communication between these hosts. But it's important to understand anything that claims to do switching is going to operate the way we describe a switch to operate. We are simply going to be describing the rules of switching. For these hosts to communicate with one another, they each need IP addresses and MAC addresses. Now, since a switch only facilitates communication within a network, this tells us that all of these devices that are speaking through the switch must belong to the same IP network. In this case, that IP network is the 10.1.1.x network. In this lesson, we're going to illustrate everything that the switch does to enable communication between host A and host D. Now, in the last lesson, we described the host role in all this. We described that the host is going to generate some data to send to host D, and then add a layer 3 header to that data, which includes the source of host A and a destination of host D's IP address. Then host A is going to perform ARP to figure out the MAC address which correlates to that destination IP address. Then host A is going to add a layer 2 header, which indicates host A's MAC address and host D's MAC address. All of that we described in the last lesson, and all of that still applies. In this lesson, we're just going to be focusing on the switch. And if you recall, a switch is a layer 2 device, which means they're only going to be using the layer 2 header to make their decisions, which means the switch doesn't look at the layer 3 header at all. In fact, everything after the layer 2 header, from the perspective of the switch, is simply considered data. You and I know there's a layer 3 header in here, but from the switch's perspective, it doesn't care about that layer 3 header. It's just going to make its decision based upon the layer 2 header. In fact, we can actually get rid of anything IP related on this topology, because if all we're doing is focusing on the switch, we don't actually need to consider the IP addresses that are communicating. We're going to show you everything that happens to get this data to host D through this switch. Now, I want to point out that we are starting from the position that host A already knows the MAC address it's trying to speak to. Normally, host A would have to discover this using ARP, but for our illustration, we're going to assume host A already knows the MAC address it's trying to speak to, so we can leave ARP out of this illustration entirely. With that said, let's go ahead and explain how switches facilitate communication within networks. Switches use and maintain a MAC address table. A MAC address table is a mapping of switch ports to MAC addresses. Each of the hosts in our topology are plugged into this switch in a particular port. For instance, host C is plugged into port 6. Now, every different switch out there uses different numbering schemes for their ports. For the sake of illustrations, I'm just going to use these numbers 5, 6, 7, and 8. A MAC address table then is going to include the mapping of a particular switch port and the device that's connected to that port, meaning it's going to know that out port 7 exists a device with the MAC address B2B2. Now, this MAC address table doesn't start out populated. In fact, it starts out empty. And as data is flowing through this topology, the switch will populate this MAC address table. Beyond this MAC address table, the switch is only ever going to perform 3 actions: learning, flooding, and forwarding. If you understand these 3 actions, then you'll understand how switching works. Every switch you come across, regardless of the platform, regardless of the vendor, regardless of the code version, is only going to do 3 actions. These are actually the rules of switching in general. So let me show you how they work. So host A is going to start by putting this information on the wire. That will arrive on the switch on port 5. And this is going to allow the switch to perform its first action, which is to learn. The learning action has the switch update its MAC address table with a mapping of the switch port and the source MAC address of the received frame. Meaning, on port 5, this switch just received a frame with a source MAC address of A1A1, which allows the switch to update its MAC address table, indicating that the device on port 5 owns the MAC address A1A1. That is the learning action, and the switch is going to try to learn the source MAC address for every frame that the switch receives. Now the switch has to figure out what it's going to do with this frame. It's going to look at the destination address of that frame to determine that this is meant to be delivered to the device which has the MAC address D4D4. Now, you and I know that that device exists over here, but this MAC address table lists everything that the switch knows. So at this point in time, the switch does not know what port the MAC address D4D4 exists out of, which means the switch's only option is to duplicate that frame and send it out all ports. This is the only way the switch can ensure that whatever owns that MAC address does get this frame. Now notice that the switch did not forward the frame back out port 5. When it duplicates the frame and sends it out all ports, it's going to send it out all ports except the port that received the frame initially. The idea there is that if this frame arrived on port 5, there's a good chance that the destination does not exist back out port 5. So that is the flooding action, and all other hosts in this network are going to receive a copy of this frame. Now when host B and host C receive this frame, they're going to look at the destination MAC address to determine that they are not the intended recipient for that frame. They are therefore simply going to silently discard that frame. Host D, however, will be looking at the destination MAC address to realize it is destined to host D, and host D will accept that frame for processing. And that is how data will get from host A to host D. Now, inevitably, host D is going to generate a response to send back to host A. This response is going to have a source MAC address of host D's MAC address and a destination MAC address of host A's MAC address. Host D is going to put this response on the wire, where it'll arrive on the switch on port 8. This will allow the switch to once again perform its learning action. It's going to update its MAC address table, indicating that something just arrived on port 8 with a source MAC address of D4D4. This allows the switch to create this mapping. Now, the switch is going to try and figure out what it's going to do with this frame. And once again, it's going to look at the destination MAC address A1A1 to determine where to send this frame next. The difference, however, is that now the switch knows how to deliver a frame to A1A1. It knows that A1A1 exists out port 5. This will allow the switch to simply forward that frame out the appropriate switch port. That is the third action of the switch, the forwarding action. The forwarding action allows the switch to deliver a frame directly to the appropriate switch port because the destination MAC address exists in the MAC address table. This will allow the switch to send that frame directly to host A. And that is how the response data will go from host D to host A. Now, at this point, anything else that A and D need to send to each other will simply go directly to each other. Now that the MAC address table is populated with either of those hosts' MAC address, anything A and D send to each other is going to go directly to each other without having to do the flooding action, which means host C and host B will not get a copy of any of that data. And that wraps up our discussion of how switches work. Again, switches use and maintain a MAC address table, which is a mapping of a switch port to a MAC address, and switches perform only these three actions. And if you understand these three actions, you now understand how any switch for any vendor on any platform facilitates communication within a network. But before I let you go, there are two more ideas I want to leave you with. Our illustration involved host A sending a packet to another host. But everything we just showed you would still apply if this wasn't actually a host and it was instead a router, and host A was trying to send something to the router in order to speak to something else out on the internet. The only thing that would be different would be the layer 3 header. And as we discussed, the switch doesn't even look at the layer 3 header to do its job. Which means this process is exactly the same whether host A is speaking to a host on the local network or trying to send something to a router in order to speak to something on a foreign network. The second idea I want to leave you with is that we showed you how traffic flows through a switch. We illustrated host A sending something through the switch initially to host D. Understand that switches have MAC addresses. Again, any NIC has a MAC address. But you'll notice that this MAC address was completely uninvolved for any communication going through the switch. But what if you wanted to send something to the switch? Well, if you're trying to send something to the switch, then this MAC address would be involved. But not only would the switch need a MAC address, it would also need an IP address. And at this point, if you've configured an IP address on the switch and you're trying to send traffic to the switch is essentially acting as a host on the local network. It's going to follow all the rules that we described in the prior lessons that hosts follow in order to communicate on a network. The switch's MAC address And also its IP address will only be used if you're sending traffic to or receiving traffic from the switch. Perhaps you're trying to log into the switch using Telnet or SSH in order to manage the switch. But for any traffic going through the switch MAC address and IP address will be completely uninvolved in the process. The switch is merely going to perform these actions over here in order to facilitate communication within a network. And that wraps up part 1 of our lesson on switches. In the next lesson, we're going to unpack 3 more ideas. We're going to describe unicast flooding and explain how that's different from a broadcast. We're going to briefly define VLANs and show you how these actions are different or not if VLANs are being used. And finally, we're going to show you how communication flows through multiple switches, showing you how these actions are still the same regardless of how many switches data is flowing through. Either way, your key takeaways from this lesson are understanding these first 2 bullets up here. I hope you enjoyed this video. I want to thank you for watching, and we'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson from my new course on networking fundamentals. I'll be releasing the entire first module for free here on YouTube. I want this course to be the ultimate networking fundamentals course, and since I'm still scoping out the outline, you could have a say in what topics will be covered. Let me know in the comments below what subjects you want included in this course. Otherwise, remember to like and subscribe. And of course, if you learned something from this video, the best way to thank me is to share this video. It's a small act of gratitude, but one I appreciate greatly. I hope you enjoyed this lesson. I want to thank you for watching, and we'll see you in the next one.